Canadian Tire hockey puck transmission mounts. So I'll see if I can draw this in a way that it makes sense. So we've got our hockey pucks. Our hockey pucks are just shy of 1 inch thick. So let's say we have our bottom hockey puck, just like that, and then we drill a hole through it for our bolt. We'll determine this in a minute. Now we've got that plate that comes through here, right? So that plate has a hole in it that's 1.5 inches, right? So 1.5 inches. We know this plate is on the thick edge is 3/8 of an inch, and right here it's like 1/4 of an inch. So we're going to split the difference and probably go 5/16 with the thickness of our step. But anyhow, so that thickness comes into play here. Our next hockey puck is going to get machined down basically like this, okay? So overall, that would be 1 inches. We're going to take 5/16 out, and then that will leave this part here, which will be 1.5 inches. So we'll have this part of rubber that will go down through this hole and stop at the lower hockey puck. And the reason we want this bit is this is what stops the bushing from sliding side to side in the hole. And it also, like, if we were to make anything else like this bushing big enough to fit in there, then it would be metal on metal contact, and it would either A, would make noise, B, be rigid and negate the dampening effect of a rubber bushing, or wear out. So this is what we're going to do. So the overall, okay, so now on top of that, we have to put a washer, right? And another washer on the bottom. So I'll make these washers out of probably 3/16 material. And then most likely we'll find a 1/2 inch bolt to hold it all together. And a nut, right? So that is the correct way to make a hockey puck body mount. Hockey pucks, Canadian Tire. So our goal today is to repair or replace the transfer case mounts, and we're going to use these hockey pucks as our rubber. So the first thing we have to do is get a jack underneath this transfer case, take the weight off it, get the bolts out, and see what we have to do. Whether we can just machine the rubber to replace the rubber that was already there, if the metal's still good and the bolt's still good. If not, we'll make everything new bushing, new washers, new bolts, which I'm guessing that's what's going to end up being. But start taking it apart now and see what we find. Wow. You can see just how bad it is here. Watch when I jack it up. Maybe you see it better when I let it down. Right? So Obviously that's no good. So new rubbers will address that problem. So what size is that? At least an inch. 15/16. Measure our overall thickness. We're going to machine one hockey puck with a step so that it'll actually fit inside this opening, and then the other hockey puck will go on. That'll leave enough space for the metal, and then we'll cut a bushing that is exactly probably 2 inches, I'm going to say, and then cut 2 washers on the plasma table, bushing, get the right size bolt, and put that all in there, and it'll be just like factory, just the NHL version of it. So I'll sketch this all out on paper just in case it's not clear. You'll be able to understand it when it's on paper. But our hole, according to my trusty veneer, is 1.460. 1.475. So it's basically 1.5 inches, just a hair under 1.5 inches. And our thickness, 0.394. Yeah, it's 3/8 of an inch right here, but it's only about 1/4 right here. So I'll probably split the difference, because I'm not going to weld this up and machine it to the correct thickness. Obviously, it's not going to last me another 20 years. So we'll just make it so that it works, and we'll go from there. Now I got this piece of polished and ground. I'd like to have just a little piece of tubing like that the bolt would fit in. That would be perfect. But I don't have anything here, and I don't feel like going for a drive to get it. So we're going to make our bushing out of this. So I'm going to do this on 2 lathes, because this lathe I have set up for production. It doesn't have a parting tool, and I don't feel like taking the time to set one up just to part it off. But this is a stronger drill and a more accurate drill. So I'm going to drill the hole, turn down the diameter 2 inches or so, and then I'm going to turn it around and do the same on that end. It's easier to hold on to. It'll be more rigid than it will be to try and turn down 4 inches and drill 4 inches and then part all that off. So it'll all make sense, maybe. I got to turn the jaws around though. Now, we've got to put a drill in the turret. Probably use this position. Set that there for a minute. And our drill, chuck. Shit. Well, I looked everywhere. My problem is my drill chuck is for 1/2 inch shank and my drill is 5/8 shank. I never do anything out of the ordinary on this machine, so it's not set up for accepting different size drills, especially over 1/2 inch. If it's anything bigger, it's usually like an insert drill or something like that. So to solve the problem, I'm going to get lots of hate on the internet about this, but I'm going to do it anyway. We're going to, the socket is for my tools in the turret is 1.5 inches, and it just so happens this bar that we're using is 1.5 inches. So I'm going to clean that off. So you can tell all your friends this is the video about how to make hockey puck body mounts the wrong way. And then we'll hold the drill in the jaws. Well, I could have done this drilling part in the milling machine, but I don't feel like running 3 tools today. 2 would be bad enough, so. Anyway. And we're drilling. Okay, I need to set my depth. I don't know if you can see it over there, but I won't show you on this video, but my turret has a graduated dial, so I'll be able to tell when I've drilled in 2 inches or more just by looking at it. $400,000. I could put it, the turret has a feed, but I don't want to push too hard in case it shoves the drill into the jaws further. I'm going to wind this up a little faster. We're at 500, we'll go to 625. I think. One inch. She doesn't like that fast. Go back to 500. Yeah, that's what I was afraid of. That's 2 inches. We're going to go just a hair more, just for insurance. 2.2 inches. Now we'll turn this around, drill the other end, and then I'll reverse it, put it in the jaws, and turn it down to our final diameter. This lathe is a 1967 Hitachi Seiko that I bought at a liquidation place. It was a basket case when I got it. Input pulley had stripped on the shaft, and that's when they stopped using it, but the maintenance has stopped long before that, so we completely blew this thing apart right down to every nut and bolt and replaced all the bearings, all the seals. Fortunately, this thing the design of it is incredible. It's a Japanese machine, and maybe that explains it, but like all of the ways are automatically oiled. So every time I turn on the cross slide, it runs a pump in that end of the slide, which delivers oil to all of the ways. And the same thing with the turret. Every time it changes a tool or changes position, it gives a squirt of oil to the ways as well as the turret itself. So like the accuracy of this machine is like, it's deadly. Like the ways did not wear at all since 1967. When I run this thing in production, the only thing that affects my my repeatability and my accuracy is the temperature. So if this thing's been running all day, obviously the coolant and the machine heats up and it grows, and I might have to adjust my boring bars by like 1 to 2 thousandths of an inch to compensate for the temperature. But then by the next morning, I'm back to my original specs. And just absolutely amazing for a machine that, you know, built in 1967. So we're 1.6 inches in. There's other videos on the page of this machine working, and as this channel grows, we'll have even more, with probably more descriptive on how we set it up to do production work. Obviously, you know, in today's day and age, it's all CNC, and CNC does have its place, but for my little shop, I don't have the volume to justify such a large expense for a machine that, you know, lets me drink my coffee while I'm running it. So this thing is, in some cases, it's almost as fast, and maybe in some cases faster. Like this thing, it'll thread a bar, 1/2 inch bar in seconds, like way faster than any CNC lathe doing single point could ever do. So there, we got our hole drilled in, the same on each side. So now I'm going to change positions. I'm going to pull that out of the turret, put it in the jaws, and I'm going to turn the outside diameter down to my bushing up 2 inches or so. And then once I'm happy with that, I'm going to transfer it over to the little engine lathe, and then we'll part it off to length. So we're going to turn this down to 1 inch. So our hole that we're going through is 1.5 inches. I want to leave a 1/4 inch of rubber on either side of this bushing. So we'll turn the outside diameter down to 1 inch. So I'll just set my DRO here. 1.487, that's not right. This is one thing that they didn't, the lathe didn't come with in 1967 that it should have. All right, and then set our Z, or Y, I mean, or no, it'd be our Z, I guess. We'll face it. Running a little fast on the speed right now, so I'm going to try and slow it down. Not that one. There we go. Downside of that is you get the long stringy chips, but better surface finish. Maybe we'll do something a little different on the next one. So I just want to confirm my diameter before I do the final pass on this. One and 10 thousandths. So my DRO said 1 and 7 thousandths, so I can adjust that. We'll turn the DRO into 1 and 7. And then change it. 1.010. Enter. Confirm that it's going the right way. Turn it into 1 inch. There. Knock the corner off. And turn the bar around. You can see there now what we're getting close to having our bushing.
Now once again we'll face. And then we'll turn. So I should be spinning this a lot faster, but the hot chips fly everywhere. Now back in 1967, they designed this machine to do everything with either high-speed steel tooling or some brazed carbide tooling, not this insert tooling. So, you know, it's really, I shouldn't say it's not designed to run that fast, but it's not practical to stand beside it while it's doing it. So that's a little bit of a trade-off with a manual machine. That and the mess that coolant makes. I'm sure there'll be some comments from people wanting to know where my coolant is, and I found that it's cheaper to buy new inserts than it is to keep the thing full of coolant, that it just sprays all over the floor. There are places where I use it, more critical parts that I want to keep cool while I'm turning them, but as far as tool life, I don't care.
Okay, put her in reverse, and wind her out for the finished pass. that, we burnt a hole through the air hose with the hot chip. All right, we'll reposition and move over to the engine lathe. There. We got two 1-inch diameter, 2 inches long, 5/8 bore bushings for our hockey puck mounts. There. I was able to find my 1-inch drill, so I made it go a little quicker. And we've got two more rubber mounts. Perfect. Okay, so now we need washers. We need a washer for the top and a washer for the bottom. So going off what was in there already, I could probably reuse these, but since we're doing everything else new, why not make the washers new too? So those are 2.5-inch diameter, and we know it's a 5/8 hole, so we'll go just a few thou over 5/8 when we plasma cut it, and that's what we're going to do next. And it's pretty simple to do everything right on the machine here. So draw a circle, 2.5 inches. We'll drag that right to our 0, 0 on the center. Draw another circle. We're going to go 25 thousandths over, so 0.650. Draw circle, 0.650, enter. And we'll drop that right there. Then we just got to highlight it and move it to where we want. Now, I've got some old scrap plates over there that are 15 inches diameter. So I'm just going to draw a 15-inch circle so I know what my boundaries are. And then we'll fit that, you know, within the circle. And we'll zoom to the window, turn the machine on, set the amps, initialize it. So now it's initialized. So there we have it. All the parts we need for our hockey puck body mount. So just to demonstrate how this goes together before we put it in the truck. That bushing slides through. Then that'll go through from the top. Put the other hockey puck on below. Right? That's our gap for the bracket that holds the transmission. You can see that our bushings are flush. That's what stops it from over compressing. Then we have a washer on the top and a washer on the bottom. And a nylock nut. And there we have it, one hockey puck body mount, transmission mount, whatever mount, rubber isolator. So let's go put them in the truck. All right, let's see if we can get these suckers in here. So we'll take our puck with the turn down on it, put that in the top. Then we'll take our full puck, put that in the bottom. Drive our bushing down through both. Or try to. There. Okay. Put our washer on top and our bolt down through. I noticed one more problem. This whole thing is shifted back probably a ½ an inch, so I went looking, and our engine mounts are buggered as well, so the engine is just falling downhill. So I got to try and pry this forward enough to get the bolt down through the hole. So hopefully we can get these in here, and then I'll address those another day. So what we're going to have to do, you can see that gap that we have? This whole engine is tilting that way because take a look at that engine mount right down in there. It's completely gone, right? So the whole engine's fallen over. So what we're going to do is put the jack under this side of the engine and lift it a little bit so that it will go back down on the far side, and we can tighten our two, where am I pointing? We can tighten our two transmission mounts, and then we can come up here and address this at a later time. There she goes. And that's it. Brand spanking new Canadian Tire hockey puck transmission mounts.